we're going to get into a little bit more challenging, but it's not too bad, going from prefix into prefix. So if you're still not sure on just going from a prefix to a base or a base to a prefix, I want you to jot down your questions so that you can ask me when we're face to face, or send me a remind and we can jump on the Google Meet and get some one-on-one time to try to work it out. If you're ready, we're going to go ahead and move on to the two-step metric conversions with going from prefix to prefix. So you can see here, I have added our little roadmap just to kind of help us get us going. And once again, you will start to notice a pattern, and you won't really need that as much. But it's good to definitely use to get started to help your brain recognize the pattern that you're going to be using. All right, so let's jump in here. We have our base unit, the mole. So this one looks a little funky because it does have so many letters, but the mole is the base unit for the amount of substance that we use in chemistry. So you can see the prefix here is the centi, and then we're also with the prefix, the little m, which is the milli. So I'm gonna go ahead and I'm gonna find those here to find out where we're at. So centi and the milli. Okay, all right, so those are both small prefixes. So we're going to start and we're going to end up here. So we're going to start and end up with the smaller prefix. So that means in order to do that, the only way, we don't have an arrow that just kind of like, that like does a U-turn. We have to follow the arrows. So in order to get back from here, from the start to get to the finish, we have to follow the arrows. All right, so we're going to have to go in this direction. So we're going to have to go into the base unit, and then we're going to have to follow it back in this direction to get back to the small unit. So it's 2 arrows, 2 steps, 2 equalities. So let's write down the equalities that we're going to use. So we're going to use the centi. So for every 1 centimole, there are going to be 10 to the negative 2 moles, okay? And then for every 1 millimole, there are 10 to the minus 3 moles, okay? And we know that with both equalities, we can set up our fractions one way or the other. So we can use them in the inverse form if we need to. All right, so our first step when we approach these problems is always the same. We're going to write down the given information. And I'm going to write, let's see if I can write small enough to fit it all here. All right, so our first fraction, we have the centimole on top. So that means that this right here is going to have to be the denominator so that we can cancel out that unit. Actually, I'm going to move this over so that we have some space to put it all out. So I'm going to move this guy over here a little bit onto the table. I have such big handwriting and I want to make it clear enough for you to see. All right, so the centimole, in order to get it to cancel, must be in the denominator, and that'll leave the 10 to the minus 2 mole on top. So what have we done when we set up this fraction here? We've canceled out centimole and we're in the base unit. So we have arrived here in the base unit. So now we can follow the map. So we're going to go from base unit into the new small unit that they wanted us to convert into. So I'm going to go ahead and set up my next fraction. So because mole is the numerator in the previous step, it becomes our denominator in the current step. So here I'm going to use the mole, the 10 to the minus 3 mole, and I'm going to put the 1 millimole on top. So what happens when I set the fraction up that way, my moles cancel, and the lone standing unit is the millimole, which is exactly what the problem asked for. So because all of that canceled out correctly, I know that I set the problem up right, and we can go ahead and simplify the numbers by using our algebra skills. So we have 769, so 76.9 times 10 to the minus 2 times 1 divided by 1 times 10 to the negative 3. So we can go ahead and put that in the calculator and we can solve the problem. So we've got 7.69 times 10 to 2 divided by 10 to the negative 3. All right, so when we do that, I am going to get 769. Okay, so that was the answer that I got. So I'm going to put it over here. Remember, my final answer, the number of sig figs must match the number of sig figs given. So I have 3 sig figs given. I have 3 sig figs when I solved it the first time, so I don't need to put it in scientific notation to make it match because it's already there. So my final answer is 769. So it is 769 millimoles. All right. Let's look at the next one here. Get rid of this so we don't have all of it on there. All right. Clean this guy up here, our little road map. Won't take me but a minute. All right, let's look at this next one here. So we have 0.67 big M CD. So CD is candela, that is a base unit, and the big M is our mega. So we are in the mega. So we are going to be starting over here in the large units, and then we're going to end up in a big G. So the big G, I look on the chart here, is a giga. All right, so we're going to also end up in the large unit. So that means I'm going to have to go into the base first, and then I'm going to have to go back into my large. So that tells me I'm going to be using the 2 equalities, which are the equalities here I highlighted on the chart. So we're going to be using for every 1 gigabyte or gigacandela, there are 10 to the 9 candelas. And then for every 1 megacandela, there are 10 to the 6 candelas. All right, so with that, we can go ahead and start solving our problem. So I'm going to write down the known. So I'm going to go over here again so I have the room. So 0.76 megacandelas is where we're starting. So because I'm starting in megacandelas, that means megacandela must be in my denominator. So this guy right here, this is the equality I'm using, 10 to the 6 candela. All right, so once I've set it up like that, what happens is megacandela will cancel, and I'm now in the base unit candela. All right, now we can use our next prefix. So because candela is up top in the previous unit, it will go on the bottom in our current step. So we've got 10 to the 9 candela and 1 gigacandela. So what happens here is candela cancels, and the unit left standing is going to be a gigacandela, which is nice because that is exactly what our problem asked. So that means we set our problem up correctly. So now we can go ahead and simplify the mathematics. So 0.67 times 10 to the 6 times 1 all over 1 times 10 to the 9. All right, you can put that in the calculator. You can use your log skills to simplify, however you're comfortable solving the problem. So 0.67 times 10 to the 6 divided by 10 to the 9th. All right, So my final answer, I get 0, 0, 0, 6, 7. Now, in true sig fig fashion, technically, you are in the correct number of sig figs because all these zeros in the front don't count. But we're going to simplify how it looks. So we're going to go ahead and just put it in scientific notation just to get rid of all those extra zeros, and it kind of cleans up the answer. So I'm going to move the decimal 1, 2, 3, 4. Now, if you have it in scientific mode, your calculator probably already gave it to you in scientific notation, but I did not have my calculator set up in scientific mode, so I'm going to go ahead and just move my decimal. So I'm going to get 6.7 times 10, and I move the decimal 1, 2, 3, 4. So it's a small number, so I moved it 4 places. It's a very small number because of it's a decimal, so it is a -4. So my final answer is 6.7 times 10 to the -4 gigacandelas. All right, guys. I want you to make sure you understand how to do it and do a couple practice problems. If you have any problems at all while you're doing it, please jot down any questions you may have. Send me a remind, or we can get on a Google Meet, or save your question and we can talk about it when you see me face to face.